Okay, this is Mr. Martin. This is video for section 4.1 for honors geometry. This section we're going to be talking about detours, which we've actually done a couple of these proofs already, and the midpoint formula. So let's talk first about the midpoint formula, same as what you did in algebra. So we're going to define M as the midpoint of a line segment joining the points x1 comma y1 and x2 comma y2, and the midpoint is just the average of the x values and the average of the y values. So that's really all this is. It's the average of x and y values. Remember, when you take the average, you add up how many there are, and then you divide by the number that there are. So in this case, since there's 2 points, each point has an x and a y coordinate. You add up the 2 x coordinates and divide by 2. You add up the 2 y coordinates, divide by 2. If you have trouble remembering it, maybe that'll help you. So just a basic example first. Given the points 1, -2, and -3, 5, find the midpoint of the segment joining them. Feel free to pause the video and then restart just to double check that you know how to do it. So the midpoint is going to be 1 plus -3 divided by 2. That's the average of the x's. And then -2 plus 5 divided by 2. That's the average of the y's. And if you simplify that, you should get -1 and 3/2. Alright, so that's that. Moving down to something just a little bit more complicated. As always, make sure you write down questions that you haven't asked me when you get to class. I won't always remember to ask you if you have questions, so make sure that you advocate for yourself and get those questions answered. Alright, so example 2, given that 5, 4 is the midpoint of a segment with one endpoint, -2, -3, find the other endpoint. So now I know that the midpoint is 5, 4, and I know that one of the endpoints is -2, so -2 plus whatever that x value is divided by 2 should give me 5, and -3 plus my y value divided by 2 should give me 4. So I can set up two simple equations here, setting these equal to each other. So I've got -2 plus x divided by 2 is equal to 5. So -2 plus x is equal to 10, which means that x is going to be equal to 12. And then I've got -3 plus y divided by 2, and that should equal 4. So I have -3 plus y is equal to 8, and y would be 11. So other endpoint is 12, 11. So that's two fairly basic examples of midpoints. Moving on to some proofs using detours. So a detour proof is basically a proof where you need to prove one pair of triangles are congruent in order to get another pair of triangles congruent. So you're going to have two pair of triangles congruent in the proof, which does tend to make them a little bit longer, but not necessarily more complicated. So as always with the proofs, if you want to try and figure this out on your own, feel free. Otherwise, you can work along as I go. So I've got 4 pieces of given information that I'm going to get in here. So I've got BC is congruent to DC. I've got CG congruent to CF. I've got angle ABG congruent to angle EDF. And I've got angle AGB congruent to angle EFD. So that's our given information. Given, lots of given information. Okay, I'm going to go ahead and mark this stuff on my diagram. So I've got BC and DC. I've got CG and CF. I've also got ABG EDF and AGB. So I've got this angle over here, and EFD, this angle over here. And I want to try and prove that AG is congruent to EF. So probably what I'm going to do is just get those to be corresponding parts of some congruent triangles. So I've got 3 sets of triangles that I can be working with, and I can see right away that if I use these vertical angles, that I can prove that these 2 medium-sized ones on the insides are congruent. So I'm going to start with those. So I'm going to state my vertical angles. Angle 1 and angle 2 are vertical angles, and that's just assumed from diagram. And then I can say that they're congruent. Angle 1 is congruent to angle 2. Vertical angles are congruent. And that's going to give me enough to say that those 2 medium triangles are congruent. So triangle BCG is congruent to triangle DCF. So that's side, angle, side, and the steps I have are 1, 2, and 6. So now that I have those 2 triangles congruent, I can see that BG and FD are going to be congruent because they're corresponding parts, and then I can see after that that I'll have enough to prove the little triangles on the outside congruent by angle, side, angle. So let's go ahead and do that. So I've got BG and DF. BG is congruent to DF by CPCTC. And then I can prove that triangle ABG is congruent to triangle EDF. And this one is going to be by angle, side, angle. And let's see, my steps are going to be 3, 4, and 8. And then now that I have these triangles congruent, I can prove the 2 outside segments AG, and that should actually be EF. Make sure it's corresponding order. AG congruent to EF, and again this is CPCTC, just corresponding parts of these triangles. So we've got our 2 sets of triangles congruent in order to prove our conclusion, and that's what makes it a detour. Let's go through this next example also. So I'm given that AB and AD are congruent, and BC and this should be DC, but that's okay. We'll fix that when we do the proof. And I want to prove that these little triangles on the top are congruent. So again, we're going to have to go through a detour. Based on the information that I have here, I could prove that the left half triangle and the right half triangle are congruent. So let's start there. So I've got segment AB congruent to segment AD, and segment BC is congruent to segment DC. Notice I fixed that corresponding order there. So that's given. And then I can use my reflexive property for AC, congruent to AC. Reflexive property. And that's going to give me enough information to prove triangle ABC is congruent to triangle ADC by side, 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 steps 1, 2, and 3. So now that I have the left and the right triangles congruent, I know that these angles up at the top, which I'm going to label 1 and 2, those are going to be corresponding parts. So let's get that down in our proof. Angle 1 is congruent to angle 2 by CPCTC. And if I want to try and get those top triangles congruent, so far I've got a pair of sides and a pair of angles. So I need one more pair of sides. Maybe you see it already. I'm going to use this AE. So before I used AC, AE is a shorter segment. That's going to be part of these two top triangles. I'm going to use that as a reflexive property. So I've got AE congruent to AE. And we can't use AC because that's too much. That's more than the complete side of those little triangles. So we need to restate the reflexive property down here. Reflexive property. And now that we have that, we can prove the triangle is congruent. Triangle ABE is congruent to triangle ADE. And this one is side angle side, and my steps are going to be 1 and 5 and 6. Okay, so again, pair of triangles congruent here in order to get a pair of triangles congruent in the last step, which makes it a detour. Now, we're going to actually come back to this example in another section because once we learn a new theorem, we won't need all of these steps. Okay, we can go right from the given information and we'll know some other things that will help us to shorten this quite a bit. So again, ask me questions when you see me in class, and we'll see you next time.